All right, let's say we've got a little figure here. A, B, C, and then we're going to have a point D on the side over here. All right, here's what we know. AB equals BC, and angle B is 40, equal to 140 total. You with me there? 180 minus 40. Well, here's the other thing I know about them. I've got an isosceles triangle, so what does that mean about these two angles? If these two sides are the same, then aren't these angles also the same? They have to be the same because of the isosceles triangle. The angles are, in relationship to the sides, size-wise the same. So these two angles are, if these two sides are equal, these two angles are equal. Well, so each of those then would be what? Of those other two angles, well, it would be half of the 70. So this one's 70, this one's 70, because they've got to be equal because it's isosceles. Well, we're trying to get to this one, so that's this angle right here. What do you got there? Well, this 70 angle right here and that angle make a straight angle, don't they? So doesn't BCD, wouldn't it have to be 180 minus 70? 110. Yep, 110. Okay. So you just kind of have to work your way through it. Yes, sir?
I was just looking at.
Oh, okay. Is everybody okay with that? Any thoughts or concerns? So there's a couple on this homework assignment here that they use the same figure. I mean, the angles or whatever changes a little bit, but I wanted to show you kind of what they're go through there. All right, so again, talking about triangles a little more. We're not going to do much with them, but just kind of talk about the name, I guess. If you have congruent triangles, what does that mean?
The same.
They're exactly the same. Same size, same shape. Everything about them is the same. Equal. Equal sides, equal angles. Everything's the same. On similar triangles, though, that's a little different, isn't it? Similar triangles, okay, so you've got same shape, but not necessarily the same size. I mean, they could be, but if they're the same size, they're congruent, so you might as well call them congruent. But you got the same shape, but not the same size. And so, yeah, they're, here's an example of that. So we got a triangle there, and then we've got, let's make this one smaller, but it's exactly the same shape. Supposed to be, okay. So it's a little bit smaller. Well, let's call this one ABC triangle, and this one DF triangle. So those are similar triangles. So they're the same shape, but not the same size. Well, what that means is, one thing it means, there is some equal parts to this because the angles are equal. For example, so in similar triangles, the angles are equal. So we've got angle A and angle D are equal. Angle B and angle E, they're equal. And then angle C and angle F are equal. And sometimes you'll see the little marks like that to show which ones are equal there. So the angles are equal. They're the exact same angle, or they should be. Mine's off a little bit, but they're exact same angles. The sides, of course, are not equal, but they do have a relationship. The sides are proportional to one another. Here's what that means then. All right, so let's call the sides here P, Q, and R, and the sides over here X, Y, and Z. Yeah, so the sides being proportional means you can set up a several equations. We can write them all together here. For example, here one we could say, well, P to X, or P divided by X, has to be proportional to Q over Y. So that's one relationship we could set up, and then if we needed to, we could also set up then, all right, so if those are proportional, then so is R to Z. And you could flip those, you know, you can make the X, Y, Z on top and PQR on top, depending on what you need, but, all right, so they're proportional. They're not equal, but they are proportional. They have the same relationship there. All right, so just a couple problems here. So let's, on number one, say we go with ABC is this. And this angle right here, where C is going to be 30, and then B, I'll call it the double line one, is 105. All right, then let me flip this one around just a little bit. So this is M, N, O. All right, and this is the angle that goes with C, and then this is the angle that goes with B there. So find all the other angles, the measures of the other angles. Well, of course, one thing we know, since I've got it marked there, that angle M, it's the same as angle C, right? So it would be 30. Angle N is marked like angle B, so it would be the same as angle B there, so angle N would be 105. What about the other two? Well, that's where again we use the fact the sum of the angles is always 180, right? In a triangle. Right, we used that a couple of times here, but some of the angles in a triangle is going to be 180. So what's angle A? Well, angle A's got to be what's left over, right, out of 180. It's 180 minus these other two. So that would be 45. Yeah, 45 degrees. Everybody with me on that? And so, last but not least, then angle O. Well, if C goes with M, or M goes with C, and N goes with B, then O goes with A. So O and A would be the same, so it would also be 45. So, any questions on that one? All right, number 2 here. Let's say we've got another triangle, 2 triangles. Try to draw it here. All right, so this one's 12, this one's 14, and this one's N. Make a bigger one over here. Same shape, different size. So that one and that one. Say this one's 15, this one's M, and this one's 21. All right, so let's find the other sides there. Well, in this particular case, then, yeah, we've got the angles equal, but the sides, of course, so these are similar, but we want to find the side lengths, and so that's where we use the proportional thing. Like here, the M and the 12 go together, and so do the 21 and the 14, right? So the M over 12 must be proportional to the 21 and over 14. Line them up like that. Different ways we could do it. Of course, one way, you've got a proportion, the cross products have to equal, so M times 14, 14M must equal 21 times 12. So again, just solve that little equation. Let's see, 21 times 12, what is that? $252. So see where we got that? Just cross multiply, and those cross products are equal. And then, of course, M would be divide off the 14, get 18. All right, so M's 18. Now, how would we get the N then? Well, N's on this other one, and it corresponds to which side? The N corresponds to the 15. Now, the thing on the proportion is, you want to be sure on your proportion, like if this one's from the small and this one's from the big, then over here, same thing, right? You want the small side and the big side on this as well, because I've got it just reversed. Here it's big over small, so it's big over small. That's the only thing really you got to be careful with. So what would I put over here? Well, I'd go with the 14 over 21 in this case. Same thing. 21 in, multiply, cross multiply, and then 14 times 15. So we got 21 in equals 14 times 15, 210. Oh, that's going to be nice, isn't it? Divide by 21 then, okay. It's 10. The other one, real quick, I want to show you, was, what was it? Back on 9.3. This one out of the book. It's kind of a word type problem. All right. So a tree casts a shadow (45 meters long). At the same time, a measuring 4 meter stick casts a 5 meter shadow. 3 meters. So how tall is the tree? Well, this is another application of similar triangles, because yeah, you've got this tree here, and what we know is it is 45 meters, sorry, the shadow it casts, so here's the shadow. The shadow it casts is 45 meters taller. So it casts that shadow down like that. And then our stick here, which we know is 4 meters, casts at 3 meter shadow. So yeah, you got at the same time, so you know, of course, we're going to say you got right angles for put them at right angles there. And then it's the same time, so the shadow angle would be the same. So you got similar triangles, and so couldn't we set up our proportion here? Call it T for tree. So our tree height would be to the 4, right? As the 45 is to 3. Just set up the proportion. These two are in the same proportion as these two. Tree to 4, 45 to 3. So cross multiply, divide by 3. So 3t is 180, I believe, 45 times 4, is that 180? T would be 6. Is that all right? Okay. Questions on that one? All right, let me go with one other thing here on about triangles, and that is talk about the Pythagorean theorem. Probably are familiar with that, but just want to make sure. Make sure you are. Okay. Yeah, the Pythagorean theorem is a theorem on a right triangle. So for a right triangle, all right, let's talk about the right triangle. So the right triangle, we know we've got a right angle, a 90-degree angle. On the parts of the right triangle, we had to talk about that. The two parts that make up the right angle, those are called the legs. And then the side, the longest side, the side opposite the 90-degree angle, is called the hypotenuse. Just for some terminology there. And usually we denote the leg as A and B, and the hypotenuse as C. But the Pythagorean theorem states, then, if those are the legs and the hypotenuse, for any right triangle, then the relationship is a squared plus b squared equals c squared, right? That's our good old Pythagorean theorem. I've seen that before. Well, a couple of problems on this, or one right now. All right, so find the missing link. Okay, so let's do number 1 here. All right, so let's just go straight forward here. Yeah, let's make it 6 and 8. So we're missing, of course, in this particular case, we're missing our C, right? So the other two are A and B. So A is 6 and B is 8. So to find C, yeah, we plug those in the Pythagorean theorem, and so it's the squares of those added together that equals C squared. 6 squared plus the 8 squared is 10 squared. I'm sorry, c squared. It's true, but we don't know that yet. So yeah, that's 36 plus 64 equals c squared. So you got, yeah, c squared is 100. Well, square root both sides, if you will. Yeah, so c is going to be the square root of 110. Gave it away there. They won't all come out to be nice whole numbers. Let's do this one. A little bit different one. All right, so let's kind of backwards from what we did. All right, so let's say we've got here, this one's, this one is, let's call it 4.1, and that one looks like a 7.2. Just making some up there. So we're missing this one. Which one's missing though here? A or B, yeah. I've got the C. So you want to call this one B? So we're missing A. You could go A, B the other way too. The C has to be the one you get. Can't mess that one up. Yeah, so I'm missing the A here, we're saying. So I've got A squared plus B squared equals c squared. So in that case, I've got a squared plus 4.1 squared is, find my square button. There it is. 16.81. And then 7.2 squared is 51.84. But how am I going to get A out of that? Well, it's a little, just solving a little simple problem, hopefully simple. Yeah, I need to subtract the 16.81, that's going to be my A squared from 51.84, 35.03. And so, question?
Usually, like, I subtracted them. Would that work, like the 4.1 minus 7.2? Can we do it that way?
No, you gotta square them and then subtract them. Subtract, yeah, because they're the squares in the formula, it's the square. So yeah, you have to square them. All right, so A then would be square root both sides, right? 35.03 square rooted. It's 5 point, so yeah, it's not, they're not always going to come out exact. Since I've got one decimal place here, let's do one decimal place for the answer. It's 5.9. Anyway, there's, like I said, maybe another problem or two will come up with these right triangles, but for now, just wanted to get the theorem out of the way there. Question or concern?